There's ghosts.
What? I'm not gonna make it.
No, calculus is a subject. That's like saying the plural of science. I mean, I guess there's sciences. Sciences is a thing because there are a variety of sciences. There are a variety of sciences. I think there's really
Does it give you a hard time?
calculus.
No, there's multiple calculus.
What does give you a hard time?
You just said calculuses.
No, that's fake.
Are you guys gaslighting me?
Who's a good camera person? I'm not good.
I've never been gaslit.
Hi guys, welcome to Mr. Ye's Calculus 1.
AJ, sit down. What is wrong with your face, bro?
I just got physically abused.
Dude, we can't see your face. You were just showing your face.
Yeah, your head wasn't even in frame.
Yeah, we cannot see you.
It was literally just
They
your
were
I
looking
guess you
at.
could say AJ was sus.
You be the cameraman.
Okay, I got you.
That's actually a good idea.
Can you guys hear me?
Make sure to use the 2/3 rule, AJ. The 2/3 rule.
Wait, get some of this
Alright.
Clash Royale gameplay.
There we go. That's perfect right there. Yeah.
That's not 2/3.
What?
AJ,
Oh, yeah,
that's
yeah,
not 2/3. You gotta lower it some more. Oh my god.
I better not be going to the office again. What did I do this time?
Oh no, when he's standing, it's our first caller. Also, you want
first
this
caller
market
of the
right,
day.
so.
Yeah, look at him answering the phone.
That's too far left, AJ. Move it right. Oh my gosh. Bro, stop screwing around.
AJ, stop making it shake.
AJ, when we try to rewatch this, we're gonna like have a seizure.
No, it's just gonna be shaking.
Wait,
Oh, look
turn
at
the
that.
camera 180.
Just don't touch it. That would be so funny.
Alright, so welcome to the first lecture in calculus. This was the introduction to calculus.
Wait.
Is that 2 million viewers?
Can I be the executive producer?
I think that's 200 seconds.
No, I think that's 2 million.
2 minutes. He just live stream it in case someone's out, and then he can post it later.
What we're gonna do is we're actually gonna start introducing calculus. Okay, just stick with doctor.
Oh, she. She's Louise.
Turn the camera.
Hey, you miss one more time, I'm turning the camera to show it.
Do not. Do not.
Calculus class is going wrong.
No, it was so bad you couldn't. You don't want to see it, man.
Alright, so
No, you didn't.
I think I accidentally did earlier.
Butt cheeks.
Oh my god, Andrew. So funny.
So what is calculus? Okay, let's start with, should we talk about who invented calculus?
There's some guy with a weird L name.
Jesus.
Nah, Jesus' name started with a Y, though.
Isaac Newton and
Was he white? Was he Asian?
Oh,
So your voice is gonna translate that to the whole lot, so I need to find a way to have my voice in here. So is there any way I can do that?
Mike?
Yeah, just get a wireless microphone.
Get, like,
I think you
AirPods or
could literally
something.
put in earbuds.
Get AirPods or something. Do you have AirPods or
I
like?
literally have AirPods in my bag right now. If we're gonna do
Yo,
that.
plug it up
Those
to the
are
phone.
like $300.
be the-
He's not just gonna buy AirPods.
Or get some like Bose headphones or something, or something that has like a good mic.
Teach a lesson while wearing full headphones.
No, he could just have an AirPod in, so therefore like the mic is on it, so they'll hear.
body's trash then.
Do you want me to repeat everything you say?
Please no.
I actually want you to shut up.
Oh my goodness.
No, I'm just kidding. Alright, so because your voice is gonna be the one that's here, so I need you to be quiet for this here. So I figure out how to earphone work.
All the kids watching this are gonna love that.
No one.
Why don't you just put the camera over there, right next to you, and then record like that?
Because he wants to get the screen in frame.
Yeah, but you'll still see it if you just put it over there.
You can still see it.
Oh my god. I hate this class.
We'll figure it out with trial and error.
Alright, so what we're gonna talk about is we're gonna start with the calculus. So we start out with the calculus yesterday. Just talk about who invented calculus. So there was Newton, Isaac Newton, and also Leibniz. So a lot of time that I wanted the student to ask why, and because why is a very, very important question, and also even better is asking why not, right? So we start with some idea. It's like talking about your algebra teacher probably told you say anything to the 0 power is 1, and did you ever ask why?
No.
So you just take it because your teacher told you says anything to the 0 power, I just memorize it is 1, and you don't ask questions.
Well, they told us like that it would take too long to explain, and they never did it.
It doesn't take too long. It takes 3 seconds.
I guess it would.
The truth is the teacher probably didn't know.
Manchester City footballer Benjamin Mendy
Stop
suspended
reading
after
the Twitter
being charged.
notification.
I'm sorry. I'm
You
sorry.
want me to read everything.
Manchester City got Ronaldo.
All right, I cannot. I'm serious. We're live streaming this, so okay. So anyway, so we want to think about anything to the 0 power. So let's talk about anything to the 0 power. So anything equal to 0, anything to the 0 power is equal to 1. Your teacher says just memorize it, and it's too hard to explain, and that's that, right? And so does anybody knows why anything to the 0 power is 1? Yes.
Because the number that of the exponent shows how many of the integer, like in this case a, you're multiplying to itself. So if there's 0 of it, then it's like a divided by a, which is 1. It's kind of,
Okay,
I don't really know how to explain it better.
Okay, anybody else? No? Nobody can tell me. Yes,
The
Will?
y-intercept is
Y-intercept?
1 when x equals 0.
Yeah, what's the function though?
A is the 0th power equals 1.
Okay.
What does that mean?
Okay. All right, so let's think about it. So can anybody come up with the reason why anything to the 0 power is 1? So besides your teacher says, yes.
Is it because like a to the first, there's 1a, but if there's 0 a's there, then there's nothing there, then it's just like 1.
That would be 0.
I don't, no, not, I'm not explaining this. So like, a to the first, like that's a, like itself. But then if there's nothing, then, okay, never mind. That's actually not. No, never mind. Yeah, I was like,
I'm just thinking
I
about
think
Okay, so those are the things that you should think all the time. So anytime that if I teach you something you don't understand, please do ask me, and if I don't know, I will find out for you. But I do think that asking why and why not, and asking why is anything to the 0 power is 1, it's a fair question. And then it's a fair question for a teacher to answer that. So those are things that you want to think about all the time. So let's talk about, yes, Will?
So, I don't know if this is answering your question, but I guess if we thought of it as like an exponential function, anything to the x power. So if we go to the negative side, to -1, you're doing 1 over a to the first power. So 1 over a, and if we
But
go,
that's also teacher told you that. Also, nobody told you why either. We're gonna get to negative power as well. Okay, so let's think about it. Let's think about something really easy illustration. I only spend 30 seconds, right? So if I have 2 to the 4th power is equal to 2 times 2 times 2 times 2, and that's equal to 16. 2 to the 3rd power is equal to 2 times 2 times 2, that's equal to 8. 2 to the 2nd power is 2 times 2, that's equal to 4. So math is very pattern based. Like you think about pattern, that's what it starts with math, right? So anything to the 1 power is 2, or not anything to the 1, just anything to the 1 power is anything. Then if you see the pattern of 4, 3, 2, 1, what's the next number?
It's gonna be
Now, what's the relationship between 16, 8, 4, and 2? What's it gonna be? You divide by 2.
oh, that's actually way simpler.
I think I can explain it now.
Yeah, so, yes, next time somebody asks you,
That's what you said.
you're gonna be like, I'll explain to you, I got you. So that's equal to 1. But that also explain negative exponent as well. If you think about it, 2 to the -1, which is the next pattern, right? It's also divided by 2, which is 2 to the 1 power. And 2 to the 2nd power is 1 over 2 to the 2nd. So that is what is coming to play. Now, I'm going to challenge you to think analytically. If you were that student at that moment at the algebra class, the teacher told you anything to the 0 power is equal to 1. What will be your question to ask me next?
Why?
Well, we already explained why, but what's another situation that you can think of you don't think is equal to 1?
0
0 to what?
to the 0 power.
0 to the 0 power, right? So
0 divided by 0 is 0.
how do we explain 0 to the 0 power is equal to 1? Question mark.
So it's like undefined, and then it's also 1, but it's also 0 at the same time.
So which one's which?
So we can put 0 over 0.
0 over 0 is 1.
Yeah,
So
but
but
it's
it's
also
probably,
1.
okay, so let's talk about a process. You divide by 2 each time on
Because
the last
whenever you
one.
have a 0 under something, you can't divide it into 0.
Okay, so you were going somewhere with that. Just be patient. But the problem with your logic doesn't even answer 0 to the 2nd power. I'm going to talk about that. So 0 to the 3rd power is equal to 0 times 0 times 0, right? 0 to the 2nd power is 0 times 0. If from here you divide by 0, so that is already have a issue already. Does that make sense? And 0 to the 1st power is equal to 0. And besides, how do I illustrate 0 to the 0 power? Do I just write down nothing?
I guess.
Just write down an empty spot?
Something I'm thinking of is if, with all of them, if you multiply, like, if it's 0 times 0 times 0 times 1, and that would work with any number, it would go back to the same answer, so you could multiply. No, because then 1 times nothing, like no 0, would equal 1, if you wanted to think of it like that, but that doesn't quite make sense.
Okay,
There's
well,
no
let's
reason
start
for it.
somewhere, right? Let's start with, he said 0 divided by 0 does not define. Let's start to think about
Undefined over undefined.
what it says. Something in my notes. Okay, so anyway, so if you think about it, anything to the 0 power, 0 to the 0 power becomes a very important question for you to think about. So it becomes a calculus question, actually. Becomes a calculus question, actually. So there are calculus that you think about 0 to the 0 power. Then you say, okay, what happened to 0 to the 0 power? Okay? 0 to the 0 power. Now let's do an investigation. Let's think about a scientific approach. So instead of thinking about, like, there's a couple kids in science lab here. I know you're one, right? And you're one. And who else was it? You?
Yeah.
Okay, you. Okay, 4 of you guys. And we're gonna establish a scientific approach instead of just saying, well, we don't know it, we'll just take for granted. So what we're gonna do is we're gonna use it in some type of approach. And some type of approach is like 0 to the 0 power, we don't know, but what we can do is say, we can start with a 1 to the 1 power. That's equal to 1. But we're gonna incrementally go in smaller and smaller. So I need you guys to use a calculator to help me. So if you have a calculator or a cell phone, you help me. So I'm gonna say 0.9 to the 0.9 power. Can somebody figure out what a 0.9 to the 0.9 power is?
0.90953.
Give me 4 digits.
9095.
Okay, so 9095. So you already see that trend is going which way? It's going toward down, right? It's decreasing, right? So it's things going down. So that's 0.8. It's going down. It's from 1 to 0.9055.
8365.
Okay, so how about 0.8 to the 0.8 power?
8365.
8365.
Yeah.
How about 0.7 to the 0.7 power?
7791.
0.7791. How about 0.6 to the 0.6 power?
7360.
7 what?
7360.
Okay, so stop. So I want you to say, what do you just see on this observation? What do you see that something that you think is abnormal or something that you can see different? Let's go with green.
So when you start with like 0.9, it's only, the answer is only slightly larger than 0.9. Then you go to 0.8 and it's even larger proportionally than it was with 0.9. And once you get down to 0.6, you're all the way in the tens place. You're a full digit above 0.6.
Okay, and, okay. Kind of makes sense. I think I know what you're trying to say, but I think you described it kind of.
Yeah.
Anthony, no, don't tell me what happened yet. What happened with this numbers right now?
It's slowly decreasing.
What is decreasing?
The number is decreasing in value, meaning like it's getting smaller.
Is it an asymptote?
Is it asymptote? I don't know. So yes, Will?
It's decreasing, but the rate it's decreasing at is getting smaller.
Okay, so we are talking about rate, we are talking about decreasing, we are talking getting smaller, we're talking about ratio, we're talking about a lot of things, right? So basically, the first increment is 0.1, the second increment is 0.07, the third increment is 0.06 and 0.04. So it's actually smaller, it's smaller gap. So let's go to 0.5. So let's say 0.5 to 0.5 power is what?
0.0 or 7071.
0. What?
7071.
Okay, and then 0.4 power to 0.4 power?
6931.
6931. And so far, it seems like it's going towards 0, but it's decreasing in a slower rate, right? Just like what this says. So 0.3 to 0.3 power, what do you say?
6968.
Which is slightly higher than the last, and it starts increasing again.
Ooh.
Interesting.
It's turning around, right? It's turning the ship around, going the other way. So it's pretty cool, right? Do you guys ever look at this? It's pretty amazing. Now, this is not my lecture. This is from someone lecture. He's really good at teaching. So I watched his lecture and I stole this one of his lecture. This is one of the lecture I stole.
Nice.
So I give him credit, but you know, I don't claim this is mine. This is other people. But I thought it was interesting, so I illustrate to you. So 0.2 to 0.2 power.
It's 7247.
Okay. How about 0.1 to 0.1 power?
7943.
Okay, how about 0.01 to the 0.01?
I did 0.001 to the 0.001.
0.9549.
Good. And then we're gonna do 40 this time? Or 30, sorry, 30. What is it? 0.0001? 0.99, what? No. 9? Are you sure? Is that small? I don't think that's small.
Calculators have weird rounding errors sometimes.
It's 9990 and then 79.
Okay, so anyway, if you get infinitesimally small, then we are going to 0.000, get up the answer. And let's go with the 8 zeros.
That's too many zeros.
So 0.0, let's say 7 zeros, you're probably gonna be what, 0.9999999, right?
Yeah.
So eventually it's gonna lead to 1, right? So I thought this is interesting. Why do they turn around? Right? That's the first question.
I was gonna ask that.
Yeah, and we won't be able to answer that until we know how to take a derivative.
Oh.
But I will be able to show you what it looks like. So, can you think of a function? Can you think of a function, for example, y equals to 5x, right? Represents, if you make $5 an hour, and x represents the amount of hours you do, and y represents the money you make. So y equals to 5x. So can you think about a function represent this exact same thing? Represent exact same thing. Can you think of a function represent this scenario? invalid function represents exactly the same situations. The output is going to be the answer of this. For example, y equal to 5x, y equal to e to the x, y equal to what? Nobody can tell me?
X to the power of x equals y. That's technically the function, but that's not.
You are actually right.
Let's go, I did this smart.
Yeah, you are right. Good job. So let's do that. It says y equal to x to the x.
Oh, cool.
And if you see this graph, you see this value right here. The y values represents the result. So remember 0.9. When we do 0.9 is going to be 0.91. When we do 0.8, we get another value. See the y value? Right? If I can get there, but I don't think I can get there. But it's pretty close. And then at this point here, 0.368, the things start turning around at 0.368. Yes.
It's kind of hard to see on here. You can't really see it.
Can't really see the.
You can't see like the y equals x to the x or the 0.3 or any of that.
What your job is.
So there you go.
Oh my gosh.
You can't-
Well, you stupid.
All right, there you go. Now they can see it.
You're the camera.
They can't see your face right now, but they can see the board.
Mr. Ye's the main appeal.
Exactly.
What?
Their
If
loss.
I'm staying on that side, would it be good?
If you're like sitting like right there, like to the right of the table, yeah.
That's okay. My face is not that important. So yes, so this function is gonna go up, right? When this point will turn around and it'll come back to anything to the 0 power. So 0 to the 0 power is actually equal to 1. You can see that the y coordinate is 1. You can see that because it's approaching 1. Okay, so what this process is called? So in calculus, we start learning. So in calculus, we start with the what? Pre-calculus, which is you go into Mr. Chaparro's class. And in Mr. Chaparro class, you will learn outer algebra in the first 9 weeks. And then you will learn trigonometry and all other things, right? Yeah, you have a question?
No, I was just stretching.
Okay, so trig, you will learn that. But at the end of the last 9 weeks, the fourth 9 week, Mr. Brown is probably going to go to, let's say, its limits. Right?
Yeah.
And then, so this is the idea, it's called limit process. What we just did is called a limit process. Limit process is something that you're approaching slowly. Assume that you can get there, but you're approaching slowly. Okay? And then every year I give a same analogy, right? Every year I give the same analogy. I think the way I would like to die.
Oh, okay.
Yes, the way I would prefer to die is probably fall into a black hole.
Spaghettification.
Pretty
Yeah, it's a very environmental conscious way to die, right?
Well, but
You're
also
not-
pretty rad.
You're not keeping any material in the earth, right? And just the other like last year I kind of thought of this. Like we have so much plastic problem. Why don't you just get all the plastic together and just ship to the black hole?
That's painful though, 'cause you get
Well,
stressed
it would
out.
still be there. It would just be in a
Why
very
would you
small
put it in the
area and would
landfill?
probably create.
Would it though?
It wouldn't be good.
I don't know. I've never been there, so I cannot tell you.
That's
Because information gets
stressed out.
destroyed in a black hole.
That's true, but mass can't be destroyed.
So
So it just takes it in
That's
it.
the
So-
paradox. That's the black hole.
No, the vacuum did.
Okay.
You're getting stretched out as you're through the line.
I need your attention. So this is the thing. It's like if you were to find a location of black hole, now of course you can probably project light in there. Maybe gravity will bend it, the light over there. But just say that we were using an old-fashioned way to measure what a black hole is, and just assume that we have a very small black hole in this room. Okay, very very small black hole, and that black hole is just big as the size of marker.
Then we would.
The size of marker, just like this big, right? And I said, hey, I'm gonna I'm gonna have a black hole right in this location, right between the tiles, right between the tiles on the board. And we says, hey, how do we find out where it is? We can find out where it is, right? We can find out, we cannot take a GPS, our cell phone, we cannot stand on this black hole because I die right here.
True.
And I don't really want to die, although that will be one way good to die. And also, I think I saw a video of Tyson, what's his name?
Neil deGrasse Tyson.
Neil deGrasse Tyson, thank you. And he said there was a way to die that less painful in a black hole is by making yourself become a ball and just roll it really fast. Because your gravity is gonna pull, right? But if you roll it and you turn around, you roll it again, so you kind of average it out. So, do you know what I'm saying?
Yeah.
No, I saw an interview with him. He was talking about this. He says a less painful way to die in a black hole. He said if you keep on rolling, you can actually reduce the speed from dying. So he thought that was pretty interesting.
How long does it take?
I don't know. It probably still, you probably did die like 1 second longer than exactly before, but still you're gonna die. But you have to roll faster than the speed of light in order to make that even actually work.
So you can't do that.
So those are things that you guys gotta think about. And so how would I measure this if I have something that's right there? So I need Caleb to come up here and so Caleb's gonna be standing exactly 3 tiles away. I'm gonna stand in 3 tiles away. I'm gonna see where the black hole is because I cannot stand on top of the black hole. So what I'm gonna do is I'm gonna take a GPS and we just both take 1 step further and we're gonna come here, we're gonna see this. Okay, we're not die yet, so the black hole is fine, it's perfectly okay. So then we're gonna step 1 step closer and then we say, okay, we're still alive. And then we says, well, we're getting there, so we don't want to take 1 step. If we're taking 1 step, we're gonna die.
You take it first.
And besides, I don't really want to kiss Caleb, but it's not my fault.
That's good. That was a big crime.
So we take a half, and we can take a half a step, and then we get closer and closer. So eventually, we're gonna get to a point that we can say, well, approximately that location of that black hole is somewhere there. So that's something called limit process, just like we approach 0 to the 0 power. Except 0 to the 0 power does not both sides. Most of the limit you're approaching both ends. Most of the limit you're approaching both ends. Sometimes limit is there's not the other end. For example, if this black hole is in the wall, right? It's in the wall right here. There's no way I can approach it on the other side of the wall. Thank you. So I can get closer, 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 closer in front of this. But most of the limit you have to approach for both ends to find out what's going on. Am I going too fast?
No,
No,
this makes
no.
sense.
Okay, so let's call limit process. Okay, so let's talk about calculus.
What is it called? The
Limit process.
limit process.
Limit
Okay.
process.
Just subscribe to you, Mr. Yeah. You just did?
Okay, so limit process is very, very important because without limits, there's no calculus.
Right.
So you are approaching something slower, but assume that you can get there. Assume that you can get on top of black hole, but it's going to get smaller. So what happened is this. If you think about it, we're going to create a function that creates exact similar situations. And that function looks like this. X over square root of x plus 1 minus 1. And we have a limit. No, we don't do the limit yet. Let's think about this function. What would this function graph look like? That's the first starting thing. And if you cannot think of what a graph look like, which is, I'm like you, I cannot think what this graph is. If you just give me it like this, I cannot think of it. But think about where does the graph start? That you can think about. At which value will your graph start? Can you think about it?
Yeah.
Oh yeah.
Where do they start?
It looks like it starts at -1.
Why? What? That's really good, Luca. That's like 10 point bonus for you.
Let's go.
Just because
I was thinking of the x plus 1 inside the radical.
So you were thinking something called analytically. So let's talk about, there's 4 aspects in calculus. There's 4 aspects. first aspect is what? So this is rule of 4. So rule of 4. So rule of 4 says the first aspect you should think about algebraically, right? The second one is called graphically. The third thing is called numerically. And the fourth thing is called analytically. I don't know how to spell. Somebody can help me.
We're streaming live, bro.
Why?
Why? It doesn't matter. We get the vibe.
Y-A-L. A-N what?
A-L.
Analytical.
A-L.
Anal. And then Y.
No, no,
What
no,
do you have
no, no.
before?
Yeah, do what you had before.
No, A-N, yeah.
ANALYTICAL.
I like analytically too.
Okay, I'm ESOL student. I'm sorry. Forgive me. I cannot spell analytical.
Me
I will fail a spelling bee at third grade.
What is your first language, Mr. Yai? Real quick detour. Chinese.
Mandarin?
Mandarin, Taiwanese, is about it.
So you have a
But
few.
anyway, so this is interesting. So there are 4 perspectives to look at math. One is algebraic, which is in calculus, most of the time, 70% of the time, you're gonna deal with algebraically, in general. And 20% of the time, it's gonna do graphically. And they were really minimum here. They were like probably like, I would say probably 2% of the time. That's not exact, this is just arbitrary number that I made up. So this 8% of the time you have to think about analytically. Now analytically, just like what Luca just did. Well, I don't know what a graph looks like, but I know what a graph starts. It starts at -1 because this part cannot be less than -1. If it's a -1, then you have square root of negative number, then it will be undefined. Not undefined, it will be an imagined number, so it will not be defined. So you can say, hey, let's think about this. Let's think about it. It starts at 1. It starts at -1. And the graph is going to be some type of graph. But there's something else happen too in this function. Something else, it doesn't make sense at that one particular value. Yes.
Is it 0? Because if you put in 0 and then add 1, square root of 1, 1 minus 1, and then you'd be dividing by 0.
So what's divided by 0? Is it 1 divided by 0?
Yeah.
X.
Well,
Yeah, one divided by, that's undefined.
well, like I said, if you're plugging in 0, it's 0 over 0.
Okay, so I hear 2 people, and you start a good trend because you start kind of pushing things, and then Caleb and Shreya says, no, it's actually not x over 0. It's actually 0 divided by 0 because you plug in x. X is equal to 0 in this case. So 0 divided by 0. So 0 divided by 0 is no longer called undefined. Like what you assume, your teacher always told you number divided by 0. Thou shalt not divide by 0. But never say 0 divided by 0. It just say you cannot divide it by 0. So you automatically assume 0 cannot divide by 0. If it's 0 divided by 0, in calculus, we don't call anything. We don't call undefined. We actually call indeterminate.
What's the difference?
Wait, so.
Indeterminate. Don't
It
ask me
means
how
you
to spell.
can't think about it.
No, it's a no. It's a no. We don't know until we figure out. Okay? So indeterminate, that's the idea. So what happened is I'm going to graph this in decimals. And I'm going to graph it in that way. So I'm going to graph it. And I'm going to approach 2 different ways. One is graphically. And we're going to see what happened. X divided by square root of x plus 1. And then minus 1.
Oh my gosh, Desmos. There we go, that's it.
Okay, so we have this graph, and just like Luke says, it was nothing on the left side of -1. Nothing. Absolutely nothing. It started there. And then the y value, and it keep on going up. But nothing happened at 0. There's no asymptote. There's no nothing. Well, what actually happened?
It approaches 2.
It approached 2, looks like, right? But what happened at 2?
It crosses and goes over.
We don't know. It disappeared.
So look at this. Look at this thing.
Right.
If you look at it slowly,
They're both approaching 0 from different sides.
What do you see? Do you see something? See something odd?
Does it skip it?
It skips over.
Oh my goodness.
But it says
Oh.
no way.
Then I thought it was indeterminate. So what's
Well,
going on?
in determinate, so we don't know what a location is, but we can figure out what a location is to. So this is called a graphic approach.
Right.
If I go graphically, how do I approach there? Now, let's think about numerically, and let's do it numerically. So the thing about numerically, you can click on this wheel thing over there that looks like a clock.
Yeah.
And so it's gonna click on that, you're gonna have a table, and then you say, okay, well, we're gonna approach, we have to get rid of all those values. And we know at 0 is undefined. So we're gonna do start with negative 0.1. So this is where Caleb is. Caleb is start from 0.1. And then he's gonna get 1 step closer, so, no, well, actually 10 steps closer. Oops, my bad. We're gonna do negative 0.01. Negative 0.001. Does that make sense?
Yeah.
Can we zoom in?
I don't think I can zoom in, but, see it? You
I-
guys see it?
Icarus.
I zoomed in on the camera so they could see it.
Okay, so yeah, so that's a 0.01, 1.995. Do you see that? It's getting closer to what?
2.
Getting closer to 2.
Yeah, and then the same thing you're on the other side. You're gonna say, well, I'm gonna say 0.001 is opposite end, is my end. 0.001, 0.101, and 0.1. And the most interesting value is between that 1.99995 and 2.00005. So we can determine that it's safe to assume that it's probably more likely to be 2.
Because you find the average.
Because we go in infinitesimally small, close to that value. If we get on there, we die because there's a small black hole, like what we said before, it's like a small marker, right? We're getting small thing, we're getting closer to get there, but we're getting very, very close. Have you played with your sister or brother? Like, I'm not touching you, I'm not touching you, I'm not touching you. Have you done that before?
Yeah.
Yeah, I'm not touching you, and then somebody like do a full swing.
It's the most annoying thing ever.
It's the most annoying thing ever. You have a little sister?
Little brother.
Little brother? I'm not touching you, I'm not
I'm
touching
the
you.
youngest of 4, so.
Yeah, he's like, you cannot do anything, I'm not talking you have to do anything. So, that's what happened. So this is some situation like this. Okay, is that interesting?
Yeah.
So you think it's 2?
But why is it undefined?
Because 0 divided by 0 is, in this case, we don't know what value is, we can only say, so we can approximate the location is. But we can say, if due to the limit process, we can assume that it is equal to 2, but we cannot equal to 0 for 0. That's only like the thing that we're debating, you know. So we call it indeterminate.
Plug in 0 for x, and then you get this
Now-
ends up being 0, that's 0.
What happened is, I want you to think about the next subject. What if I have a one weird function, and you're gonna think about this function. This function cannot solve algebraically, and I will show you why they cannot solve algebraically. This function says f of x is a piecewise function, is equal to 1 and 0. And this one's x cannot equal to 2, and this one's x equal to 2. Now this is a one function here, it's a piecewise function. First of all, see if you can draw out this function. Because it's not possible to solve algebraically. There's nothing you can do algebraically. Nothing you can do. You cannot simplify, you cannot factor, you cannot do anything to it. Because f of x is equal to what? When x does not equal to 2. F of x equal to 0 when x is equal to 2. You're like, wait, what in the world is this? No, not only that, I'm going to ask you a question. I'd say limit as x approaches to 2 of f of x. What does that equal to? Like, wait, what does that mean? Right? What does that mean? So we got f of x. F of x is also known as y, right? So y is equal to 1 when x is not 2. Y equals 0 when x is equal to 2. And they say, hey, can you tell me what's limit x approach 2 of f of x?
Could be like,
I mean, one student ever could answer me so far.
it could
Wait,
just be
the
a single
limit of
point
f
where
of
it goes
x
down
of
to
x
2.
approaches.
Well, what do you think?
is the limit 1?
Is the limit 1, 1. Okay, why?
Well, because when you graph it, it's just a straight horizontal line at y equals 1. And so when you're approaching 0, your rate of change is 0 on the whole line. So when you're approaching x equals 2, it should be 1.
So I'm going to show you what he said. So you're going to say it in person. Today. So this one is y equal to 1. This time there is a open circle here at 2. Okay, so the line doesn't go through there, so I cannot draw that. But the line doesn't go through there, so there's an open circle. But at 0 it's equal to 2, so it's going to be a solid line.
That's what I did.
However, if you do a limit approach, if you approach like this, right? If you approach like this, the y value is going to be 1. So therefore, this one is equal to 1. Because you approach it from both ends. It's not what it defines us. It's how you approach from both sides. It's not what it defines us. So if you look at it defined, it's going to be, most of people is going to think it's 0. Yes, f of 2 is equal to 0. But we didn't ask you f of 2. We asked you limit as x approaches 2. They are completely different things.
Wait, can you explain that? So like, why is it 1? Like,
because if I approach it just like this, is Caleb, right? This is Caleb is going this way, and this is me going this way. It's like a black hole. But we're approaching, so we're approaching 2, what will happen? The y value is equal to 1. Even the closed circle is right here, but that's not what we pay attention. If I would ask you what is f of 2, then you're going to say 0. But if you ask you limit as an x approach 2, you already established that. You have to reach from the both sides, if necessary.
okay.
Right?
Yeah.
So that is actually equal to 1.
Wait, how does it release? Do you know what to release?
It's, this is my highlighter. That's pretty cool. So that's that. How much time I have?
You
for
have
like
6 minutes.
Oh, good. We can talk about next functions.
Let's go. I love functions.
Conceptual math is more fun.
It is. It is a lot of fun. But the thing is, you guys gotta learn how to think about analytically and how do you think that way. It's by practicing. There's no way. There's no number to write down. There's nothing to do with that. Sometimes this way, we actually approach graphically, right? We approach graphically to find answer because algebraically, can I do anything of f of x equal to 1, f of x equal to 0? Nothing I can do. I cannot go anything. I cannot simplify. I cannot do anything except graphic. So graphic is a one way to approach something in calculus for sure. So if you don't know how to graph, I remember a teacher tells me, right? One of my teachers told me, he says, well, when I went to her calculus class was so awesome. She teaches at Dr. Philip for 35 years. And her name is Miss Potts. She was legendary. Her class is like this. It's like 3 classes of this size. Every single student have 5.
Wow.
Dang.
There was no 4s, there was no 3, there was no 2, there's no 1s. There was only 5. And I was the dumbest kid there. I promise you, I was the dumbest kid. Okay.
College board didn't say anything about that. They're like, oh, that seems legit.
College board did send her a letter. College board sent her a letter says you need to be more selective on your student.
What do they mean?
She's like, you cannot pick your student.
Oh, wow.
You cannot pick, but back then you had to qualify. You have to, in order to take calculus, you have to have a 1260 SAT in order to take calculus. You cannot take it with an 1150. No, they don't allow you in. Yeah, back then Dr. Phillips that rule. But anyway, I want you to think about f of x equal to absolute value x over x. So this is actually interesting. Without graphing calculator, can you think about what this graph would look like? It might surprise you. Now, before I do that, I'm going to talk about other graphs. Before I tell you that, so we know f of x equal to x, that looks like a straight diagonal line. Does that make sense? With a slope of 1, right?
Yeah.
And we know f of x equal to x squared. It looks like what?
Parabola.
parabola, okay, the parabola has 0, 0, 1, 1, 4, 4, 0, 2, 4. Okay. Now, how about square root of x graph?
Isn't it like a V?
Square root of x graph looks like what?
A V? Oh wait.
It doesn't look like a
It
V.
goes like this, it goes like.
It looks like that. It looks kind of like an eyebrow. Right, like an eyebrow.
Here's my prediction, 2 straight lines, and they don't touch at the origin.
Okay, they look like an eyebrow. Okay, now what is y equal to, let me think about it, absolute value of x?
It's a V.
It's a v, right? Now my question is, let's start with the easy one. What does this graph look like?
It's x.
What they said, diagonal line.
Oh wait, is it gonna be like?
Maybe like,
Both of them?
maybe like both.
Yeah,
No,
because it does the plus and
Oh, it's plus and minus?
Like this way and this way.
I think it's like that.
Is it like a V?
Huh?
Is it like a V?
I don't know, is it?
is it an x maybe? Because it still
I think it's like
includes
that.
negative.
You know, like that with like that.
No, just a v. Oh wait, because that is absolute value. So I'm dumb, because I remember Craig explained it to us one time that that's what absolute value
That was
is.
what I was about, that's the definition of absolute value, good.
Oh.
Because he taught us that with vectors, because that was also magnitude.
Wait,
It was so much.
Which one do you do first? Do you do the square root? Do you do this, you square, no, you.
This is the definition, this is the definition, square root x squared is absolute value of x. Okay, we're gonna talk about a little more. Now, what would this graph look like? Absolute value of x over x.
Square root of x squared over x.
Is it like a
The way I see it in my head, and I feel like this is wrong.
Just a line on the left side.
No.
No.
In my mind, I see a horizontal, like on the negative x values, the y value is always equal to negative 1. But on the positive x values, y is always positive 1.
I think Will agree with you.
Yeah.
I think.
Will was like nodding in the back.
But it's
yeah.
undefined at 0.
In
Yeah.
quadrant 1, it's gonna be. a diagonal.
AJ, I can think now. Theoretical mathematics. If only I were good at algebra, like any algebra.
That's a kind of important, but yeah.
That's what it looks like.
Dang it.
Oh my goodness, so much visualizing.
Maybe I should just invent a new form of mathematics. That's probably what I should do.
I swear to God.
I just.